So for this module, we have a short overview of cartography and map composition. And this is important to build off of all of the other data we have, because this is really the process of creating the final map that you're going to stick in your thesis or your publication or show to your family or something like that. That's not to say that it's a difficult topic at all, but it's really an important one to keep in mind a few key things about this. So cartography is the study and process of making maps. It really kind of combines both the science, the nature of it, and the aesthetics of what we're creating to model reality and effectively communicate some sort of spatial information. Now there's a whole field of this, of propaganda maps, of how you use maps to create a certain impact on the viewer and get a certain point across, that we're not going to get into in these modules. Instead, what I want to focus on is the things that are really necessary for having a true effective map that you've created from GIS data. Now there are three major components of a good map, and they are a scale, a legend, and a north arrow. These are really crucial for effectively showing where you are on the globe and something about the map that you've created. Each one of them is quite easy to do in ArcGIS. We're going to work with the sort of design mode of ArcGIS in the demonstration for this module. But I want to go over each one of these in a little bit of detail just so you understand what it is you're putting onto the maps. First off, a scale is pretty crucial. This can either be one of kind of three different types. It can be a verbal scale, where essentially you've printed on there 1 inch is equal to 20 miles. The problem here is it can be fairly inaccurate if it gets resized. If somebody scales your map, it's not at all useful if in a digital realm, because 1 inch on a computer monitor could be quite different depending on how you're zooming in and out. So we tend to avoid those. Another one is a representative fraction. So 1:2400, 24,000, is just showing that 1 unit of something on the map is equal to 24 units in the real world. These do remain accurate if you're rescaling, but it's a little bit hard to visually pick out what that might mean. So the best scales to put on these maps, the maps that you're creating, are usually graphic or bar scales. And these are sort of like a representative fraction, but it has a line. You can see a few examples of them up here, showing what 1 meter looks like on the map versus what 1 meter looks like in the real world. Or it's showing simply that this length on the map is 10 kilometers. So these are quite easy to put in, and the ones that we're going to be working with almost exclusively. Now the second thing that we need is a legend. And this is essentially just something to explain the symbols that you've used on the map. It could be really obvious to us that a little symbol like this equals a picnic table, or a cross equals a hospital, or something like that. But those are cultural constructs that we see and we understand that may not be truly obvious to everyone out there. So it's always a good idea to have a legend on your map, particularly if you're using any sort of abstract symbols. And if you have raster data in there that are, say, topography or are density of something, you need to be able to explain what the scale you're using is, what the color ramp that you're using is. So it's really important to have a legend on most maps. Having a north arrow is also usually important, even though the default sort of standard is up is north on the page. But that's not always the case. So having a north arrow never hurts anything, and in cases where up is not north is really, really crucial. So there are a few different conventions that are used in north arrows. You can see these up here, where you have some that are true north. If it has basically the arrow on the point on both sides, it's supposed to be true north. If it has it on one side, it's supposed to be magnetic north. And if it's got both, it's supposed to be both. These are not particularly strongly enforced in sort of the amateur cartography GIS world, but do keep in mind that almost always what you're dealing with is true north on a map, so try to use one that indicates that. There's a staggering array of different north arrows that we can choose in ArcGIS, and I encourage you to play around and have some fun with choosing some of the more fanciful north arrows when we're doing the actual assignment for this demo. Now something else that we can have on there, there's a few optional things that are really good but not always vital to have on. We can have coordinates around the outside of the map. Usually it's a good idea to have these just to show where you are if it's not immediately apparent. And these can be either a reference grid, where you might have section A1, and then that might have a zoom in on that or something somewhere else. We can have a gradical that is that geographic coordinate system that we talked about in an earlier module, where it's giving us latitude and longitude coordinates. Or we could have a measured one that's some sort of projected system that's giving us the UTM coordinates or the state plane coordinates around the outside. It's possible to have multiple different coordinates systems on a single map. If you've ever looked at kind of the standard US GIS maps, they usually have multiple coordinate systems on there represented in different ways. We can also have map insets, either as a detail of an important area, so sort of a zoom in of a really important area on the map, or as kind of a zoom out, putting the context of it. So the one we see here, we may have a zoom in on something that's deemed important for the map, or we may show where we are within a country if it's not immediately apparent to the observer. We can also insert tables and charts. So we might have data on the map that are also, we want to show some sort of relationship between them. So we could have a table or a chart showing that. Just have a few examples of these here. Cases where you might want to see different measurements in addition to just the spatial location. But even more broadly, there are a few things about creating these maps that I want to make sure have been made clear to you. First is sort of a general thing. You want to be adapting whatever map you're creating to your audience and to the medium that you're creating it for. So as general rules, almost everything should be annotated if you can. Legends, scales, north arrows, these are all really important things. If you're creating something for a publication or for a report, if it's printed, it's usually better to have it in grayscale if you can. You're not always sure what the restrictions as to color are going to be. And again, you should really annotate everything you possibly can. Where things change a little bit is for presentations. If you're doing something digitally or in PowerPoint, sometimes keeping it more simple is actually better than having all of the annotation that you possibly can on there. And choosing high contrast colors are going to be a little bit more important. Now, as far as avoiding clutter and choosing symbols for these things, you really want to try to use as few layers as possible to make whatever your point is. So if you're trying to make a point about the density of cities in northern Indiana, you don't really necessarily need to have rivers and roads and all sorts of other layers on there. You want to use your sizes, shapes, and colors, so use your symbology for anything that you have to distinguish whatever important elements it is you're trying to do. In particular, polygons, usually you have to make sure you've set a good boundary color on them, or it can be very hard to see the distinctions between them. And whenever possible, try to match colors and symbols to the items being represented. So, for instance, if you're making a map that has an ocean on it, it's probably a good idea to make that ocean blue, to make water blue on a map, to make forests green. It just triggers us a little bit more strongly. However, if you're trying to distinguish between two very, very similar things, two different types of forest, or the locations of crows versus ravens, you might want to use a more abstract symbol. You might want to use something that's a little bit more abstract so that we can visually see the difference between them in a way that might not be apparent if you're really trying to match the color to the symbol. And above all else, whenever you can, try to use the standard color ramps. When we've talked about topography, we've talked about what the standard color ramps for elevation, for slope, for aspect are. Try to use one of those because it's going to cue something very distinct to anyone that's worked with GIS before. So that's really a basic overview of cartography and how to create better maps out of these. We're going to continue this discussion with a little bit more on topography and on terrain analysis and on modeling in some of the future modules here.